Hi, welcome to this video. In this video, I'm going to show you guys how to solve example number 5 in chapter 14. So as you can see here, um, for this example, we actually have two different questions. So I will go over 5A first, and if we have time, we will also cover 5B. If not, then I will do 5B in the next video. But for both part A and B, I can use a GDC. I'm supposed to use a GDC. Right? So, which means I'm not gonna focus um, on how to find the derivatives of say L and X, or how to find the derivatives of sine X, because I'm assuming that you guys are familiar with finding the derivatives. Okay. So please have your calculator with you, and let's get started. So for 5A, they want us to show, right? They want us to show how to use the second derivative test, to find the x coordinate of the relative extrema. Relative extrema means either the minimum, the min, or the max. All right. Sorry about the bad handwriting. I'm writing this with the mouse, and my f of x is this. Okay. Okay. So when they say show, that means that we need to show the workings. So even though we can use our GDC, still we must show our workings. Okay. Let's get started then. So before we let's see what we do here. So here we need to find the x coordinate of the min or the max. In other words, if you think about it, at min, the minimum point or the maximum point, my slope will be 0, and the first derivative expression is gonna give me slope, right? So I'm gonna find the first derivative. So f prime. So if I differentiate L and x, I will get 1 over x. And if I differentiate sine x, I will get cosine x. So this is my f prime. And since they're asking us to find the minimum and maximum point, I'm going to equate my expression over here. I'll equate that to 0. Right? That's when my slope is equal to 0. And now at this point, I'm not going to try to solve this algebraically. I will try to use my GDC, and let's see what we got. So I'll go to my y equals 2. I'm going to put that expression in there. So I will have 1 over x, 1 over x plus cosine of x. And I'm not going to go to graph yet, because if I go to graph right now, my zoom might be off, right? So they told us that the domain is from 0 to 2 pi. So that's what I'm going to use. I'm going to use 0, and then that will be 2 pi. Oops. And for my y min and y max, I'm not sure yet. So let's take a look at the graph, and we might have to come back and adjust that later. All right, so what we are interested in right now are the x values that give me a slope of 0, right? The slope of my f of x, which means I'm trying to find the zeros of this graph right here. So there's one over here, there's another one over there. So those are the x values where my extrema will happen. It could be a minimum, it could be a maximum, but I know for sure that when my x is like over there, that's when I'm gonna have a maximum or minimum. When my x is over here, that's when I'm gonna have a maximum or minimum. So to find the exact value, I'm gonna second trace, and I'm gonna find 0. And let's start with the one on the left. So make a left wall on the left of the 0, a wall on the right of the 0, and then somewhere close. Okay, so my first 0 is at 2.074. Let me type that down. X equals 2.074. Let's find the next value. So again, second trace, 0, and this time we'll move to the right a little bit. The left wall somewhere here, right wall somewhere on the right of the 0, and a guess value. That's enough. So that will be 4.488, approximately 4.488. Okay. So when my x is 2.074, my slope, my f of x, the slope of my f of x at that point will be 0. When my x is 4.488, the slope of my f of x is 0. In other words, they are either minimum or maximum. So now, in fact, at this point, I can use my TI-84 and figure out if my f of x is increasing or decreasing at different intervals. So before 2.074, which means on the left, this part, my f of x is positive. Sorry, my f prime x is positive. So my slope is positive, which implies that my f of x is increasing. During the two zeros, between the two zeros, my f prime is negative, which implies that my f of x is decreasing. And after my second 0, 4.488, my f prime is positive, which implies that my f of x is increasing. So what I can do now is to make a sketch. I can make a sketch here. Okay, this is 2. Let me do a better job here. So I'm gonna have a 2.7 something, 2.074, 4.488. Let me put the numbers down. Okay, and let's try to draw this. So I will have, because my f prime is positive, so which implies my f of x is increasing, and my f prime is negative, so my f of x is decreasing. My f prime is positive, so my f of x is increasing. So technically, I don't really need to carry out my second derivative test, and I know exactly where's my maximum and where's my minimum. My maximum is when my x is 2.074. My minimum is when my x is 4.488. But however, the question specifically wants us to use the second derivative test. So let's follow the instructions then. Okay. So which means if I want to use the second derivative test, I will have to differentiate my first derivative. So from my f prime, I can figure out what's my f double prime. So when I differentiate 1 over x, I'll get 1 over x squared negative. I'll get 1 over x squared, or negative 1 over x squared. And when I differentiate cos x, I will get negative sin x. So here is my second derivative, right? All right, so, and the second derivative expression tells us the concavity of my f of x. So concave up or concave down. So let's say if my f, this is just a quick review. if my say f of, and if I substitute the value in there, let's say 2.074, and I get something that is positive, which means the concavity when x is 2.074, the concavity is opening up, it concave up, which means that becomes a negative. Which means that becomes a minimum point. Okay, so when my x value is 2.074, I put that in my second derivative expression. If I get a positive value, that means it's concave up, and this extrema is a minimum. If I substitute 2.074 in this expression and I get a negative value, that means the graph is concaving down, and this 2.074, that extrema, is now a maximum point. So all we have to do now is to just test this. Okay, we just have to test it. We're going to use our calculator for this, so let's bring up our calculator. I'm at the main page, and all we have to do now is to substitute the x values in there. So let's type the expression in. So we have a negative 1 over x squared minus, the x. So now we're substituting the x with 2.074. Okay, minus sine of 2.074. And the value that we got is a negative value, which means it's the graph of f of x concaves down. In other words, this x, when my x is equal to 2.074, that is a maximum point. Okay. Let's just finish this. Let me type that down. So f double prime of 2.074 is a negative value. Therefore, when my x is equal to 2.074, this is the graph concave down, f of x concaves down, Let me just therefore x equals 2. It is a maximum point. Okay? Now let's do the same thing. Let's substitute 4.488 into the calculator, and let's see what we get. So I'm just gonna go up and just copy the expression, and we just have to change the value now. This is 4.488. 4.488. So when I substitute 4.488 in my second derivative expression, I get a positive value, which means 4.88. It is greater than 0, so f of x concaves up, so x equals 4.488 is a min. Okay, so that's it. And the results that we have right now matches what we had just now when we created the sign diagram. So you need to know both ways, but pay attention to the instruction by the question, okay? Hope you guys find this video helpful. I'll see you in the next video. Bye.